Hey guys, it's Steve here. I've had a lot of people ask me about the equinox, and as it's approaching, I figure it's a really good time for us to test the flat earth model and confirm whether our hypothesis is correct, if it can predict what we will expect to observe in real life. So, to quickly go over what the equinox is, this red line here is the equator. So, throughout the year, the sun moves between the Tropic of Cancer and the Tropic of Capricorn. So, right up here, that is the Tropic of Cancer, and then down here, that's the Tropic of Capricorn. And the sun oscillates through there throughout the year, and that's why we get the analemma pattern, why we get seasons. Now, let's go to back to 2024, September 20th, because that's the equinox coming up. Now, this is adjusted for Central Time, so the time itself will be wrong. Well, the time zone will be wrong. The time itself is correct. So see what here as the sun rises? This is what can confuse a lot of people. So let's zoom out. So see how for our observer, the sun will be rising in the east, due east, directly 90 degrees. You can see the data that the flat earth model has predicted up here at the top. At 1 degree, when the sun starts to rise, it's going to be right at east 90 degrees. However, the sun itself is not in that direct angle. So how does this happen? This is what we observe. For example, you see right here at solar noon, when you're looking straight up, we know that's where the actual sun will be. So we know that the sun is taking this great circled path, but why does it appear at the horizon even though it's way over there? Now, perspective is important to understand, for one thing. I think it's extremely important to understand that as objects get farther away, they appear to be lower in altitude. And this is how mountains appear lower. All objects behave that way. Now, going back to what we're talking about here, there's really two reasons I can think about the dome firmament in the first place. So I think if we go to a better view, we can see what we're actually looking at. If we're looking at this way, we have the dome right in front of us. So I think that's one explanation for what could happen. And another explanation is that light just bends this way. You know, we have many explanations, gravitational lensing, Snell's law, especially if the North Pole is there. It makes sense that light could bend in that way. Let me go to a bird's eye view. So I could see how that happens if there is a strong force in the center and light appears to bend that way. But we can debate over how it works. I'm just telling you what will happen. So this is what the flat earth model predicts, and we can test it and see that it will be accurate for the equinox as it rises. So see how that yellow line appears? That's what happens when the sun comes within our perspective. And it might even be something as simple as the 1 degree for every 69 miles. We don't really know. But this is what the flat earth model predicts, and that's how it works. So the difference is the apparent sun and the actual sun. That's what can confuse a lot of people.